Good morning to you all.
Good morning, sir.
Good morning. I'll have you take the question. Find the current direction in the segment AB. Current direction in the segment AB. Is it A to B or B to A in both cases?
Zero.
B bar is B naught T K cap.
The two opposite directional ఉంటాయి కదా సార్.
Mm. In the segment AB, what is the direction of current? Is it from A to B or B to A? Take the figure, all of you. First one. What is the answer? Magnetic field is which direction? This is the dot according to the coordinate system. This is our z axis. So induced EMF will be in a closed loop. What is the closed loop there? First identify the closed loop. Identify the closed loop. Observe here. So this was the closed loop. That was the closed loop. So in that closed loop, induced EMF. So just I differentiate this. This is the part. Whole thing is the closed loop here. So magnetic field is coming out in this closed loop and is changing. Can you tell me the direction of induced EMF thereby current?
Clockwise.
Clockwise or anti-clockwise?
Clockwise.
B is increasing, isn't it? Magnetic field coming out of the plane of the paper. I'm talking about in the plane, coming out of the plane of the paper. And B is increasing or decreasing?
Increase.
Increasing. So the corresponding EMF, thereby current, thereby magnetic field should try to decrease it. For that to happen, what is the direction of that corresponding current or EMF? So it has to be like this.
B to A.
It is. So current is from
B to A.
current is from A to B. In the segment AB, it is from A to B. Similar in figure 2. In the figure 2, current through segment AB is, so in this case no current in segment AB because each loop behaves like independent here. So there will be situations here. This loop is independent. There will be some magnetic field is coming out. As a result, it want to be anti-clockwise. Anti-clockwise or clockwise? Clockwise, కదా? There will be clockwise here in our reduction I1 current or E1. Outer loop also same direction magnetic field. This is I2. So if you place this is inside here, both are independent I1, I2. Even if you connect a conductor between A and B, there is no current. Only current in the closed loop will get circulated. Both behaves independently, and A to B there will not be any current in the figure 2. In the figure 1, A to B part of a closed loop, hence current will exist. I'll have to take the figure. Find the charge on the capacitor. B bar is equal to B naught T K cap. See the capacitors.
इसको स्टोरेज पे इसको नहीं रिडक्शन आ रहा सर.
So how many loops are there? Because our EMF should be evaluated in the closed loop.
5,
How
4
many
sir.
loops? So this is 1, this is 2, this is 3. So in this closed loop, what is the EMF? E1 I can call it as. Lambda is the resistance per unit length. Now E1 is how much? All of look into that, don't write anything. So what is the EMF in this first one here? A into dB by dt. What is the area?
3L square.
3L square. What is dB by dt? B naught. If I assume that B naught L square is equal to small e, This is 3. What about E2?
E not 4E. 4E, sir.
4E.
For you.
This is L. This total is 2L.
2E.
2E, sir.
Hmm. What about E3?
5E.
5.
5.
5E.
5B. Right. In which direction? Let us, I'm talking about E1. We should
Clock,
represent positive and negative. Our corresponding current will be which direction? Clockwise or anti-clockwise?
clock,
Clockwise, because B naught T K cap, that means coming out and increasing, it should decrease. So I have some resistance here, and there was a source. Clockwise and this is 3. There was some resistance here. Charge in the capacitor means at what time?
infinite.
Yes, nothing is mentioned. It is at steady state. It was at steady state. There was a capacitor as usual. I am representing with the corresponding to. What about E2 direction? What about E2 direction? Clockwise or anti-clockwise?
Clockwise.
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 Clockwise as usual. And some resistance of this one. What about E3?
Clock, clockwise.
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 Clockwise, that means this is positive, this is negative. This is. So lambda into L, if I write R, what is the resistance from this point to this point? 4L. This is 4R, I think, because L and L 3L, isn't it? Lower one, this is 3R. This is 2R. This is LL. This is 3R. And 5L, 6L, 7L. 7R is there. This will be 5E. Is it right? Verify. Corresponding circuit.
So 6R.
Emma?
Se-
Is it okay?
We are about
E1 is E2, E3. Both are all are A into dB by dt. Area of the loop is a constant.
సార్ కెపాసిటర్ కనెక్షన్ లో రెసిస్టెన్స్ తీసుకోకూడదా?
There will not be any current through capacitor branch, isn't it? And steady state. At a steady lower 5E minus 7IR minus 5R into I minus I1. Resistance can be written as resistance per unit length into length of the corresponding segment. Each part will have lambda into L, R I represented there. So now see that. Lambda into all L we have taken as R. What is simplification here? 5e minus 7IR minus 5R. This 5R correct అనేది. So 5e minus 7IR minus 12IR plus 5I1R equal to 0. దానంత 10e minus 7IR minus solve the equation, solve for I and I1. Let us verify.
I1 is equals to 5i by
I1 is equal to
5i by
5
I by 2.
5I by 2. Tell me in terms of E. Resistance can be written as resistance per unit length into length of the segment. If L is there, lambda into L. If 3L is there, lambda into 3L. We assume lambda into L is equal to R. Then upper portion becomes 3R.
కెపాసిటర్ సిరీస్ లో కూడా పెట్టచ్చు సార్.
ఏమా
అంటే ఈఎంఎఫ్ ఇండికేట్ చేయాలి కదా సార్, కెపాసిటర్ సిరీస్ లో కూడా పెట్టచ్చు సార్. అది
capacitor is already given.
సిరీస్ లో పెట్టచ్చు సార్ అక్కడ ఈఎంఎఫ్
సిరీస్
కెపాసిటర్ సిరీస్ లో పెట్టచ్చు సార్. ఆ రెండు
దేనికి సిరీస్ అమ్మా?
అంటే కెపాసిటర్ అంటే మధ్యలో ఉంటుంది కదా సార్, అది అక్కడ పెట్టచ్చు సార్.
ఆల్రెడీ ఇచ్చేసాడు. కెపాసిటర్ ఇస్ కనెక్టెడ్ లైక్ దట్. నో ఫైండ్ ద ఛార్జ్. దాన్ని మనం ఏం చేయలేము, ఇంకా రిమూవ్ చేయలేము. ఇంకా
ఈఎంఎఫ్ ఇండికేట్ కదా సార్, ఆ ఈఎంఎఫ్ అక్కడ పెట్టి వచ్చేది సార్ అంటున్నాను.
కెపాసిటివ్ బ్రాంచ్ లో పెట్టడానికి ఛాన్స్ లేదు, ఎందుకని దట్ బ్రాంచ్ ఈస్ కామన్ ఫర్ బోత్ టూ లూప్స్. సో E1 చేస్తే మనకి ఓన్లీ లెఫ్ట్ మోస్ట్ సెగ్మెంట్, E2 ఈ రెండు సెగ్మెంట్లో చేయొచ్చు అనమాట. E2 రెండిట్లో పెట్టచ్చు, E1 ఈ రెండిట్లో పెట్టచ్చు. కామన్ బ్రాంచ్ లో రిప్రజెంట్ చేయలేము మనం. Tell me I and I1 in terms of E.
Sir, I is equal to minus 10e by lambda L. I is equal to minus 10e by
I మైనస్ వచ్చే ఛాన్స్ లేదే.
I is equal to 5e by 7r.
5e by 7r. I1.
I is equal to I1 వచ్చేది సార్.
I equal to
Sir,
I1.
I1 కూడా సేమ్ వచ్చింది.
5e by 7r.
Yes sir.
Now I keep polarities here, some plus, some minus, q, which I don't know. So now write loop equation in the direction. So after solving that, we can go for this. Q by C minus 2 plus 4I1R next ఎంత అవుద్ది? minus 3 minus 3 into I minus I1 equal to 0. Substitute I and I1 value. you will get charge on the capacitor. Randomly I kept the polarities there. Up is positive, lower
Q
down
is
is
equal
negative.
to CE by 7.
Q is equal to
CE by 7.
C 3 na CE na
CE, sir.
CE by 7 na.
Yes, sir.
Any other answer other than that? I is equal to I1 వచ్చిందా?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So Q is equal to CE by 7, where E is equal to B naught L square. So C B naught L square by 7 is the charge. So first we have to get the EMFs there. That EMF E1, E2 cannot be represented in the branch which contains capacitor, because that branch or that segment is common for both. Hence we cannot represent E1 and E2 there. Segments we should represent. See the direction of induced EMF, thereby induced current. Correspondingly keep the polarities.
కెపాసిటర్ లేకపోతే సార్ పెట్టవచ్చు సార్.
Capacitor లేకపోతే క్లోజ్ లూప్ కదా మీకు.
అట్లాంటిదే ఒక సమ్ ఉంది సార్.
Current also flows. That's the only difference. EMF అనేది capacitor ఉన్నా లేకపోయినా only these segments has to be represented. If capacitor is not there, if any resistance is there, obviously current flows in that segment. In this case, we are talking about steady state. There is no current in the through capacitive branch. Four R means R is equal to lambda into L. If length is 4L, obviously resistance is equal to 4R. So what is motional EMF part? So if the conductor is moved in the uniform magnetic field, we can treat like a source. So this is BVL, up is positive, lower is negative. We can treat like a source here. Suppose same conductor has velocity V making an angle theta here. So we can treat this as V sin theta and V cos theta. So it can become like a source once again. Obviously we are talking about magnetic field going inside. So V sin theta into corresponding length L. This is positive, negative. So a perpendicular component will contribute for the EMF in the rod. V cos theta does not contribute for it here. So now this can be concluded for uniform magnetic field. In the uniform magnetic field, we have a conductor length L. Separation between the two endpoints is D. So it is equivalent to a single conductor, straight conductor. So moving with the velocity V. So this is T. This once again it is BVD for it. Only distance between the two endpoints is required. That is normal to the magnetic field and normal to velocity. ఆ కాంపోనెంట్ ఎగ్జిస్ట్ అవుతుంది మనకి, దానివల్లే వస్తుంది అన్నమాట. So take the result here. This here. Suppose we have a V-shaped conductor here, and rod is moving with constant speed V. This is angle alpha. So find the current in the circuit. Find the force required to move the rod with uniform speed. I'll have to take the question. Magnetic field is going into as usual. You can take lambda is the resistance per unit length for all the segments. For all conductors, lambda is the resistance per unit length. So at any instant, initially assume that started from the apex. Initial position is from the apex one here. So I draw bisecting angle. This is x. This is x. From the initial position, this is Vt. So equivalent circuit has to be drawn. This is magnetic field is going into, and the velocity is like this. What are the corresponding equivalent circuit? What is the source? So BV2x. X by Vt. So sine alpha by 2. Cos తీసుకున్నాను sin అంటే ఇది L అనుకున్నాను. So this is lambda into L. Is lambda into 2x. Is lambda into L. So now it is the current I. Total resistance we can write lambda L plus lambda L plus lambda into 2x. Substitute L and x in terms of T. Alpha is a constant.
वैसे क्या कर सकते
సార్ I కాన్స్టెంట్ వస్తుంది సార్.
VV tan alpha by 2 by lambda into secant alpha by 2 plus tan alpha. Tan alpha by 2 by lambda into
secant alpha by 2 plus tan alpha.
secant alpha by 2 plus tan alpha by 2.
tan alpha by 2.
I was just a constant.
సార్
IT constant and force versus T graph. Any
సార్
graph
I
FT?
కాన్స్టెంట్ కాదు కదా సార్.
Passing through origins are force and time.
సార్
Okay.
స్ట్రైట్ లైన్ పాసింగ్ రాదు.
Is it T proportional to T or T square?
Proportional to T.
Proportional to T. Okay. EMF versus T.
Passing through origin.
Proportional to T.
Proportional to T. Only I is a constant. EMF is a function of time. Force is a function of time. But current is constant.
Sir, అక్కడ ప్లస్ I cap.
Plus I cap sir.
DL bar cross B bar, I think minus I cap.
సార్ మనం అప్లై చేసిన
మనం
plus I
అప్లై
cap.
చేసిన ఆపోజిట్
Right. The external force is plus I cap. This is FB bar. So F external bar is equal to plus I cap. Force is I into DL bar cross B bar from the basic definition. So suppose that a rod is rotated with angular velocity omega about fixed. This is A, this is B. So this is A, PQ. PQ. Which is positive, which is negative? Which is positive, which is negative? V cross B. This is represented like a source. So this is P, this is Q, this is B omega L square by 2, where L is the length of the rod. Where L is the length of the rod. Writing equation, P is the air potential, Vp minus Vq is nothing but V omega L square by 2. That can be written. I'll have to take the result. Find the EMF induced between P and Q. It is rotated about A. The ring is rotated about A with constant angular velocity omega. R is the radius. We can treat like two rods. One is connected from A to P. Rotated with omega. AP kada. What is the length of P? I think
R
A would be this AP
R
is
60
equal to R.
60 R.
This is R here. Which is higher potential? Magnetic field is going into V cross B. Potential at A minus potential
Sir,
at
P higher potential.
V cross B.
AP
Which is
అంటే
higher
R
potential?
theta కదా సార్.
Smaller angle.
No, no, AP length is equal to R, radius of the semicircle.
Sir,
Which is higher potential, A or
Sir,
P?
yes, sir.
Yeah.
A higher potential.
A is higher potential, isn't it?
Yes, sir.
This is positive, this is negative. AB. And one more conductor, A to Q. This also has omega. Evaluate AQ. AQ length is how much? This also A is positive again. VA minus VQ again. B omega, what is the corresponding length? So if I extend this line here, 60, 120, 120 into this is 30. Yeah?
3
AQ is equal to 2R cos 30. Yeah?
Sir, root 3 R.
Right. Root 3R whole square by 2. Which is at higher potential,
Yes,
P
sir.
or Q?
Yes, sir.
Right. A when compared with AQ, A is at higher potential, Q is at lower potential. Q positive or negative?
Q negative.
Q negative. P negative or positive?
Negative.
Previous situation low
Negative.
P is also negative.
Negative.
P is negative, Q is negative. Only A is positive. Out of both P and Q are negative in the figure. Look into the figure there. Which is at higher potential, VP or
VP.
VQ? Which is at a higher
P, sir.
potential?
P.
Into B omega R square.
P, sir.
So this is equation 1, this is equation 2. 1 minus 2 jadama. 1. 2 minus
2
1
minus
jadama.
1. Sir.
2 minus 1 implies what do we get?
Omega R square.
VP minus VQ is equal to B omega R square. So obviously VP is greater than VQ. Potential of P is greater than potential of Q.
సార్ బయట ఎందుకు వచ్చింది సార్?
ఎక్కడమ్మా?
VA minus VP equals to B omega R square బయటకు రావచ్చు.
VA minus VQ is equal general equation B omega L square by 2. L is the length of the rod. Length of the rod is root 3R. AQ distance. So VP is greater than VQ. Both are negative. AP is equal to R. AQ is equal to root 3R. AQ is equal to root 3R. VP is greater than VQ. So initially rod has started from the green line here. So resistance less rod was given initial velocity V naught and a force F is equal to F naught V is applied. Find the speed of rod as a function of its displacement. As a function of its displacement. Lambda is the resistance per unit length. Rod do not have anything, but remaining conductors have. So this one is the initial position of the rod. Initial position of the rod. I'll have to take the figure. First of all, what is the EMF induced? BVL kada, we can write E cross B. This is BVL. There is some resistance here. There is some resistance. There is resistance. Rod do not have any resistance. Only the conductor. ఇది X అనుకున్నాం అనుకోండి మనకి. This is lambda into L. This is lambda into X. This is lambda into X. As a result, there is a current flowing in the circuit. I is equal to BVL by resistance is how much? Lambda into L plus 2X. Where X is the displacement from the initial position. Now write the free body diagram for the rod. DL bar cross V bar will be like this. This is FB. Already F was there, acceleration. We can write F minus FB is equal to mass into acceleration. Get V as a function of displacement. So F is already given to you. What is the value of F? That is
F naught.
F naught V kada. FB is nothing but I into B into length. So M into V dV by dx. So I, the whole expression can be substituted.
Sir, V is equal to V naught plus
V is equal to V naught plus
V naught F naught X by M
F naught X by M
minus B square L square by M lambda
B square by M lambda
into ln of
ln of
L plus 2X by L.
L plus 2X by whole by
L, sir.
I contains X there. Acceleration is equal to net force is equal to m into a. That's the only thing we have written this. How to write that equation? Before equation, F naught V is there. Substitute I here. I is B square L square V by V will get cancelled out, I think, isn't it?
We will get cancelled.
Yes, sir.
Yes, sir.
That's the story.
V naught అంటే ఏంటి సార్?
V naught is the initial speed, isn't it?
Yes, sir.
Given velocity V naught, it was given in the question itself.
Okay.
సార్ 2m లాంబ్డా వస్తుంది.
Emma?
b square l square by 2m లాంబ్డా వస్తుంది.
Square h square by 2 long by 2 ఉందమ్మా.
Yes, sir. Yes, sir. Once.
Okay. Right. I'll have to take the question. What is the current in the circuit at any instant? Constant angular velocity omega. Magnetic field is assumed that going into B omega. What can be written it? B omega L square by 2. So the I is the current flowing. This is E. Polarities are not known to us. Even if the constant or variable we don't know. By writing equation, what we get here? I is equal to, if I write equation, minus my B omega L square by 2 minus E by R. E I don't know, plus or minus C, anything can break in this. I substituted minus C. Polarities are not mentioned. Maybe a variable time, function of time also. So constant angular velocity means what is the net torque on the rod?
0.
0. So this is mg acting on this, and there is a current flowing in through the rod here. Due to current flowing, there will be, each element will experience a force. Torque due to magnetic force should be same as torque due to gravity. So what is the torque due to magnetic force? X into df. If I take an element x from here, some width dx, torque due to magnetic force. df is nothing but I into b into length dx. This is 0 to L. So I b L square by 2 must be equal to mg into entadi L by 2 cos or sin at any time t. Sin omega t. Substitute I. Tell me E. Is it cos omega t or sin omega t?
Sin.
Okay. Use a triangle. Any answer?
Sorry, mgr sin omega t by bl.
mgr
Sin omega t by bl.
sin omega t by
bl
by
minus b by
blr.
bl. Sir. Yes, sir.
2 ఉందా ఉన్నా?
Minus b omega L square by 2.
So E is a function of time, not a constant.
ఒకసారి మళ్ళీ మొత్తం చెప్తారు.
So rod rotates here. As the rod rotates, EMF is induced here. Due to EMF, there will be a current. Due to current, there will be a torque. Due to torque, the rod will be having some angular acceleration. So omega want to get affected. Now for that to happen, I want to connect a source E such that a current flows, and this EMF has to be such that here net torque on the rod has to be zero, so that it moves with a constant angular velocity omega. దానికి ఏం చేసాం మనం అట్ ఎనీ ఇన్స్టెంట్ ఒమేగా టీ ద అమౌంట్ ఆఫ్ యాంగిల్ రొటేటెడ్ బై ద రాడ్ విత్ వర్టికల్. ఆ ఇన్స్టెంట్లో ఈఎంఎఫ్ రాసాం, కరెంట్ హ్యాస్ టు బి ఎవాల్యుయేటెడ్ దేర్. ఐ ఫైండ్ అవుట్ చేసాం ఆ లూప్ ఈక్వేషన్ వేసి. in this I is this, where E the EMF of the next external source, which we do not know the polarities, not even the constant are not here. Generally I have written that minus E. And torque due to magnetic force and torque due to gravity, if it be zero, so that rod moves with constant angular velocity. Net torque should not exist. Alpha is equal to zero, omega is equal to constant. That condition we utilized. So that instant we have drawn free body diagram. We evaluated torque about the hinge about which it is rotating, about O, which is rotating here. So torque due to the magnetic forces about O, torque due to gravitational force about O must be zero. So both has to be same in order to have, because both are opposite direction. So self-inductance here, suppose we have a coil. If I send current I here, there will be some flux linked with this. Flux is proportional to the I here. So flux is equal to some constant to I. L is the coefficient of self-inductance or self-inductance. If I is variable, it is nothing but minus dy by dt minus L di by dt, where L is the self-inductance of the coil, corresponding closed loop. Suppose we have an inductor there, so I is increasing. What is the duty of inductor now?
Oppose.
Opposes the current.
It opposes such that the inductor induces some EMF. There will be some EMF. Its magnitude is mod E, that is LdI by dt, and its direction is always opposes the cause. What is the cause here?
Increasing current.
Increase.
Increasing
Increasing
current.
current.
So induced current has to oppose the cause, and it is increasing, so it should decrease. So inductor behaves like a source now, such that, so this is the current I which is increasing. So induced current is in this direction, I induced. So it will be opposite to it. It want to decrease. Similarly, if I is decreasing, same direction of decrease అవుతా ఉంటుంటే, so it behaves like a source. Once again, LdI by dt, the whole magnitude is LdI by dt. Here also magnitude is LdI by dt at that instant, and induced current is aiding the current. It is. So it want to add the already existing current. ఇక్కడ మనకి it opposes the already existing current. Draw the figures. In both cases, it opposes the cause. So it doesn't allow the changes. Inductor does not allow the changes to occur there. I'll have to take the question.
E by 2R.
E by 2R. Initially, position is at 1. Switch is in position 1 for a long time. Simply, I can draw. So, what was the resistor given there? E and R. What was the current here initially? I1 అనుకుంది. Simply E by R అనుకుంటా.
Yes.
Now this is 2R, this is L, this is 4L. Now position 2, what was the current here? Will it be I1 same as it was there, or suddenly current changes? So flux initial should be same as the flux final. Immediately after placing to position 2, don't write all of listen carefully. The current changes to I2 such that flux will remain as it is. Flux initial flux ఎంత మనకి Li1, final flux ఎంత L plus 4L into I2. So what we end up here, I2 is equal to
I1 by 5.
I1 by 5. So immediately after switch is placed to position 2, suddenly the current changes to I1 by 5. All of you noted down. So immediately after position here, current becomes I1 by 5. Find the total heat produced in the resistor. Now decay of current starts. So we can write equivalent to this one here. A resistor 2R and a single inductor. Let us say there is one mutual inductance. Everything is isolated system here. And this is 2R, and there is a current I2 flowing. What was the heat from energy conservation? U inductor plus, there was no, so UL plus heat energy, UL final, UL initial. Final anyway 0. Finally current becomes 0 here. What is the energy stored in the inductor? So whatever the energy stored initially in the inductor suddenly becomes heat energy developed in the resistor. So half I1 into I2 is equal to I1 square by 25. This is H. Substitute I1 E by R. Energy stored in the inductor is how much? Half Li square only. So this is the amount of heat developed in the resistor long after switch is closed. All of you take the question. After steady state is reached, and the meaning ending. This is a rod here. Rod was there inside the inductor there. With rod, whole system has inductance L. Steady state at a meaning ending. At a steady state, current in the circuit is constant. I1 is constant long after switch is closed. This is E by R. Steady state means current through the circuit or inductive branch remains constant. Growth of current lo మనకి we reach a steady state there. That becomes E by R for us. At that instant, that we take it as T is equal to 0. The rod in the inductor was suddenly removed. Then what will happen? Does the inductance change or not? Does the inductance change or not? This
Yes,
becomes
sir.
L by
Sir.
eta. It was given in the question. Abruptly decreased eta times L by eta. At that instant, immediately after removing, will the current in the circuit will be same as I1 or not?
No, sir.
So immediately after removal, immediately after the removal, the current suddenly changes. Can you tell me what is I2?
10 times of I1.
Yes. So flux initial is equal to flux final again. The inductance doesn't allow that to change the flux there. So L into I1 is nothing but L by eta into I2. So I2 is equal to eta times of I1, where I1 is equal to E by R. So this is the story at t is equal to 0. From this onwards, we want to find the current in the circuit as a function of time. This is E, this is R. So there is a current of I2. This is L. Again, same story. At any instant, I is the current in the circuit here. So E minus L di by dt minus IR equal to 0. So that implies di by dt is nothing but E minus IR by L. Get the variable separable, that is we got di by, there was no change at all, the regular equation, dt by L. What are the limits will get acted? What is t is equal to 0? What is the current?
I1.
No,
I2.
I2. We're starting from I2
I2.
to I at any time t. That was the difference.
Sir, L by N di by dt was, sir.
Emma, L by eta, right? This is L by eta. It could L by eta. So immediately after removal, current suddenly goes to I2. From I2 onwards, what is the current as a function of time? Okay, today we stop here. Tomorrow we continue. Complete the question.
Sure.
I hope that everybody is writing the notes.
Yes, sir.
Right. Right. Tomorrow we meet.
సార్ అక్కడ లిమిట్స్ I2 to I ఎందుకు తీసుకున్నాం సార్?
అవునమ్మా, t is equal to 0, కరెంట్ ఇన్ ద సర్క్యూట్ ఈజ్ I2. ఇదేగా గ్రాఫ్ లో చూసాంగా.
సార్
ఆ ఇన్స్టెంట్ దగ్గర నుంచి మాట్లాడుతున్నాం.
ఓకే సార్.
Right. Okay, we meet tomorrow.